This is the easiest Math Olympiad I've ever seen. Watch and see. We are told to solve a to the power of b minus b to the power of a, and that's 17. First thing we do is just to rewrite the left-hand side. Okay? To do that, we can just write it in this form, that a to the power of b, we can just raise it to the power of 2 over 2, since we are looking at expressing it in form of difference between two squares because of this minus. So on this, we now write it from the laws of exponent. We can now bring in this fraction here. So this can now be a to the power of b over 2, then all squared. Okay? We have to do the same thing to b. So b will now be b to the power of a raised to the power of 2 over 2 will now be the same thing as what? B to the power of a over 2, then all squared. Because of this square, we just factored out the 2. So we are going to substitute it into this particular term. So we'll now have something like a to the power of b over 2 all squared minus, do the same thing. Instead of writing it like this, we just have to do b to the power of a over 2, then all squared is equal to 17. Now we go to defining of terms. So we can now say let x be, let x to be equal to this term in the bracket, which is a to the power of b over 2. And we'll now assign y to be, let y to be b to the power of a over 2. So in this form, we'll now write the whole term in the form that x squared, since x is now this item in the box, minus y squared, and that's equals to 17. At this point, the next thing you have to look at is that this middle term is clearly a difference of two squares. You know that in difference of two squares, whenever you have a squared minus b squared is the same thing as a plus b into a minus b. That's typical theory of difference between two squares. If you expand this, you have this back. So we are going to apply it here in the sense that we have it that x plus y into x minus y is now equal to 17. If you look at this point now, we only have a positive solution. So this clearly tells us that x should always be greater than y, so that we won't have a negative solution here. Okay, because if y is greater, if you minus these two, you always have a negative solution. So that you have it that x is greater than y, and y should also be greater than what? 0. This is for the laws of what? Exponents. So since you actually know this, we'll now see that we'll now look at the factors of 17. 17 always have a factor of 1 and itself, no other factor. That means 1 times 17 can be a factor, and also 17 times 1. Then when you have 1 times 17, okay, to give you the 17, if you do 1 minus 17, it gives a negative solution, which is not what we needed. So this is actually not a factor. But if you do 17 minus 1 is a positive value, and 17 plus 1 is also a positive value. So this is a clear example. On getting this now, you see that we use this solution. That means x plus y is equals to the 17, and x minus y is equals to 1. Okay? So by elimination, to find the value of x, I will simply add the two equations because the coefficient of y are the same. So if I add these two, I have it that 2x is equals to 17 plus 1 is 18. Divide by 2, divide by 2. If you divide by 2, you observe that x is equals to 9. So x is 9 in this particular term. Then let's work out the value of y. To do that, we'll put x to be 1 in any of the equation. So that will now be, I'll choose equation 1, x is 9. 9 plus y is equals to 17. Okay? So to get the value of y, just minus 9 from both sides. You have that y is equals to 17 minus 9. Y is equals to 8. Okay, y is 8, x is 9. Remember that we said that x is equals to b over 2 and y is equals to x. Remember we said that x is equals to a to the power of b over 2 and y is equals to b to the power of a over 2. So we can now write this that, and we've got our x to be 9 and we got our y to be 8 from the solution we solved. This clearly tells us that for x, we have it that a to the power of b over 2 is equals to 9. And for y, we have it that b to the power of a over 2 is equals to 8. So basically, to remove this particular fraction in the power, we can just square both sides for this one and square both sides for this one. If you square both sides, this power will cancel out. We have a to the power of b is equals to 9 squared is simple, 81. Then for the next side, we also have to square. If you square both sides, you can now see that this 2 will cancel out this 2. That means b to the power of a is equals to 64 because 8 squared is 64. At this note, you can now see that we'll try to solve and compare. Okay? That means I can write 81 in terms of 3 to be that a to the power of b is equals to 3 to the power of 4. And I can write 64 to be in base of 2, which is b is equals to b to the power of a is equals to 2 to the power of 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, 2 power 6. Now we find a way to express this. Let's break this one down. We can now see that we have it that b to the power of a is now equal to 2 to the power of 2 times 3. It still works because 2 times 3 gives 6. We'll now take this to be in a bracket. That means b to the power of a will now be equal to 2 squared is 4. 4 to the power of 3. Okay? If you look at this very well, by simple comparison, a to the power of b is 3 to the power of 4, and b to the power of a is 4 to the power of 3. That shows that a is what? A is actually 3, b is actually 4. Okay? So in this particular problem, a is 3, b is 4. If you enjoyed this class, please give it a like, share it to your friends. See you next time. Do not fail to subscribe to this channel for more.